Hello, I'm Justin, and today I'm here to talk about NumPy array slicing. So first I thought I'd begin with a recap of Python lists, right? So you can skip ahead if you already know this. So here we have a regular old Python list with 5 elements, 2, 4, 6, 8, and 10. We can access these elements by using list indexing. Now in Python, and generally most programming languages, lists are 0 indexed, meaning that the indices start from 0. That means if we wanted to access the first element of this list, we would do mylist brackets 0. If we want to access the second, we would do mylist brackets 1, and so on. You can also use negative indexing, which works backwards. Another operation that lists support is list slicing, extracting a subsection of a list. Mylist brackets 1:4 tells Python that we would like to get all the elements starting from index 1 and ending at index 4, but not actually including the last index. We could also slice everything after a particular index, or just get the entire list. You can also have two-dimensional lists, which are basically lists inside of a list. You can access things inside two-dimensional lists by using row and column positions. For example, to get the third row in this two-dimensional list, we would do mylist brackets 2. To access individual elements in a list, we specify the row and column like so. Mylist brackets 1 brackets 2 will give us the element at the first row and second column, in this case 16. So next up we have NumPy arrays, right? And NumPy arrays support all the operations that Python's lists do, slicing, indexing, and more, right? So you might be wondering, why use them? Well, there are a couple reasons, right? One is that they're faster, another is that they're more memory efficient, and finally they support more features. One feature being element-wise operations, for example. Now, how do NumPy arrays do this? One way is that they keep data in arrays homogeneous, or of a single type. They also do some other cool stuff, but that's a bit advanced and beyond the scope of this. Anyway, creating a NumPy array is as simple as importing NumPy and typing np.array around a list of values. If you've created a list beforehand, you could also use a variable name for that as well. Creating a two-dimensional array is just as simple. You can access items in the same way as well. But for 2D arrays, this is really where the magic happens for NumPy. Suppose that we wanted to ask Python to get the first column of this two-dimensional array. That might require a bit of looping or transposing the array if you're fancy, right? But in NumPy, it's as simple as doing this. To break this down, right, this colon means that we want all rows, and then we have a comma, and then the column we want, in this case, the one at index 0, which will give us 2, 12, 22. We can also perform slicing on this as well. Suppose we wanted to get the second and third columns of the first and second rows. We could just do 2d_npr brackets 1:, 1:3, which tells Python we'd like to get everything after row 1, right, including row 1, and then the columns starting at index 1 and ending at index 3, but not including it. So this makes handling large datasets or even matrices a lot easier. So NumPy arrays are a good thing to have in your arsenal. Now, to show off what NumPy arrays can do, I've taken the liberty to create a Jupyter notebook, and we can try running some code. So I'm going to import NumPy as np to let Python know that we want to refer to it as np by nickname, right? And let me make a new NumPy array. Now if we print this out, right, we can see it looks like what you'd expect, right? Where you can perform slicing on it as well. Right? We could get the last item by doing this, and so on, right? Now if we wanted to create a 2D NumPy array, right? Let me change this. Alright. You might want to make it look a bit prettier than this, right? But anyway, here we have a two-dimensional array, right? That consists of 3 subarrays, right? Now to get the first column, right, I could do NP array colon 0. Should give me 1, 6, and 11. And let me print that out again so it's clearer. As you can see, 1, 6, 11 is indeed the first column, right? If we wanted to get the last column, right, 5, 10, 15. There you go. So yeah, those are NumPy arrays. Pretty cool. Try messing around if you have time.